Yeah. Hi, folks. So today we are going to discuss about domain-driven design, also very famously known as DDD, and we will also touch base upon Conway's law, which states that the kind of software that an organization produces, it's an exact mirror of the communication pattern that happens within an organization. So we will come to the specifics of what this is. But even before that, we will discuss about what DDD is exactly and why behind it, right? So it's one of the decomposition pattern of a monolith into microservice architecture. Now, why do we need to split a monolith? Should be the first question that you should be asking yourself. So let's imagine a situation where you are trying to build your own product. Uh, you have not yet found the product market fit. So the team that you are building with, you just care about velocity at that moment, right? You try to ship things very quickly, try to find the uh, like product market fit and adjust a lot according to the customer's requirement in the initial phase, right? So that kind of becomes your guiding light, and while you keep the core of the product intact, you shouldn't really deviate a lot, but the deviation will be there for sure. So let's say you start building something from point A, and when you reach to the point B, when that is the product market fit you have found, and what's that? Uh, it's basically when the product clicks with the customer, right? The customers will want that product more and more, and that kind of product will sell to more customers, right? It caters to a lot more prospects. So now you have decided that, okay, you are moving ahead with that product, and every new thing that you are going to add will be a addition around the core product itself. So till this point, you have a team, a very closely knit team, which contains all the backend engineers, front-end engineers. If your product also runs on mobile, so you will have Android and iOS engineers and infra folks, right? DevOps team where they will be responsible for all the deployment and the infra related stuff related to the entire product. Sorry. So let's say at this point, you have the product ready to scale from that position, like from A to B. You have found that okay, you want to grow this product, but at this point, you have also acquired good enough customers, and you want them to give them a very good time, like very low downtime. The product should be fast, and a lot of things which comes under the agreement, right? But what happens when the company scales, when number of engineers that you are working with grows, when the number of features also grows in the product, right? The team grows, feature grows, and the number of customers are also growing. Can you continue with monolith for a long time, right? Answer will most probably be a no. Reason being, in a very big, closely knit team, it's very hard to figure the responsibility. Like what portion of the person, what portion of the team should be responsible for this particular feature. So let's say taking an example of an e-commerce website, it can have a lot of different flows, right? User authentication related flow, product management, inventory management, orders, even payment integrations. So in the initial phase, you are building all of the logic inside the same monolith, deploying everything together, and all the changes go live at the same time when the monolith deployment is complete. Now, let's say you found some issue, right? The auth team, let's say some part of orders, right, is not working correctly. You have to roll back the entire monolith to a previous version, fix it, fix the bug, and redeploy, right? So as your customer base is growing, you cannot really afford such kind of downtime. So if you think in a way, since you reverted the entire monolith, authentication was also part of the same monolith, right? So it will be even the authentication flow, which has nothing to do with the order flow, which was affected, it will also get affected. Primarily because it lies inside the same monolith, right? The entire part is being deployed. So it takes some time for servers to actually go back to the older version and spin up once again, right? So there will be a little downtime associated, and your entire infra will be down. So you can manage, definitely, there are ways to manage this. But what I'm trying to say is, you probably need a separation of concern, and you should be very, very quickly to figure out who should be the one to fix it. It's very hard in a very big, closely knit team to figure out that who should be the right person to fix. Okay. So now I think you now understand the gist of why do you need to break a monolith into microservice. And that is primarily due to separating the concern and ease of deployment. We will come to these points later. But what I'm trying to focus right now is and this is in exact uh, tandem with Conway's law. I'll read it out. What Conway's law is that the organizations which design systems are constrained to produce design which are copies of their communication structure. Very similar to what we just discussed. Let's say, as you can see in this example, we have a large team which contains all the engineers, and I'll talk specifically taking backend engineering in context. So let's say you have all of these backend engineers. It's one large backend team. They will, from the day one, they like anyone is not going to think about separating from day one, right? People are given a task, they do it, and they do it mostly in the same code base. So it usually leads to a monolithic architecture as shown in the picture here. Now, as I was talking about separation of concern, what we did was, let's say we split the entire team into four different teams: T1, T2, T3, T4. And we picked front end engineers, like one front end engineer from the pool of front end engineers that we have, one back end engineer, one mobile, or one infra. So let's say T1 contains now one back end engineer, one front end engineer, mobile M1, and I1, right? So okay, the team one now consists of this backend, front end, mobile, and infra, and they will own a certain workflow in your inside within your entire product. So let's say we have a couple of different workflows, as I was talking in about that. Let's say first one will be user auth, right? The way user comes up and register themselves, the way user logs in, the entire flow is taken care by user auth, right? So this is one flow. The second flow can be the orders. So order management. Third one can be payments. And let's say fourth one be inventory, right? So now that there are definitely more like business logic in a monolith or in an e-commerce website, but we will focus on these four at this moment. So let's say the team one is responsible for user auth, right? So anything that goes wrong in user creation or user login or authentication related stuff, you can directly pinpoint that, hey, it's the T1 folks that should take a look into this, right? So if there is some issue in backend, the backend guy in the T1 is going to take a look. If there is some UI issue, the front end person is going to take a look. And the I1, that the infra person, once the change is done, he or she is responsible to deploy that, right? So so let's say this service one becomes the user auth service, right? It can contain everything related to user. And similarly for T2, it will have B2, the backend person, the F2, M2, and I2, right? And once again, it's not really necessary that every team is going to have, let's say, for example, mobile engineers, right? Some team may or may not need it. S- Some of the team may have infrastructure, like the person dealing with infra, and some team might not have, and some might also even share the resources, right? Some team might share the one single backend engineer is shared in between two teams, right? So it can happen based on the organization strength and the requirements. But for the sake of example, I'm kind of distributing all of the engineers into individual team. Similarly, T3 will have B2, F2, B3, F3, M3, and I3, like engineer split. And each team is going to take care of one particular floor. So let's say T2 is going to take care of order management, T3 is going to take care of payment, and T4 is going to take care of inventory, right? So, and since we have the team split, there is a very, very clear indication, there is a very, very clear separation of what each team owns. That will result into a microservice based architecture. It happens actually other way around. First, initially, what happens is there is a big meeting. It's also called as event storming or brainstorming event, where when you are trying to split a monolith into microservices, every stakeholder, be it engineers, product designers, product management, folks from sales as well, right? They will come up in a room and they'll try to give inputs around how a microservice, like initially how your product should function, right? And then it's up to the person or like the architect to to design microservice, right? Which of the components should be included in a microservice? It's up to the architects and engineers to decide, right? So now, when you have created a microservice, then the discussion starts that okay, which microservice should be owned by which team, and how many engineers it should have, right? So, for example, there is no hard and fast rule of how many engineers should a team should have when you are breaking the monolith into microservice. But when, let's say, for example, when Amazon was trying to split, they had this concept of two pizza team, where they would think that a team should only contain of so many number of peoples that can be fed with two pizzas, right? You should not have more people, a lot of people in team, or else you will end up creating kind of a monolith uh, code base itself, and it later becomes a distributed monolith, which is a pain in itself, right? So I'll deviate a little bit from here. That I was reading this book, and there was a statement that a distributed monolith is even worse place to be at if you compare it with monolith. For example, a distributed monolith will have all the disadvantages of a distributed systems and a monolith combined together. Now you have to take care of that. So it's very, very important to segregate the responsibilities in between teams and as clear boundaries as possible, right? Only under certain circumstances, or like when there is a dependency in between team, there will be definitely dependencies, but it has to be as less as possible, right? So, and it should not be that all four teams or like all n number of teams should be involved all at once in a project. One, if like let's say there is one project going on, one team, two team, or at like three teams can work together. But it shouldn't be the case that your entire organization, even after you have split it into multiple distributed teams, is working on one single project. Then you are going back again to the same closely knit team, right? So yeah, I think that should be it. Yeah. So what I basically wanted to say is the kind of, and here's what Conway's law comes into picture, that if you have a big team, right? Where it contains of all the front-end engineers, back-end engineers, infra, and the mobile folks, right? All inside a one team, and you are at a very, very lower side of the scale, right? You are still in the early phases of the product development. Even if you have shipped, you don't have like a lot of confidence around your product. You are still finding a product market fit. You will mostly end up in a monolithic architecture. And in no ways I'm saying monolithic architecture is bad. It's just that it's a very, very good starting point, and it can be a very good option to consider up until a certain point. I think after that, and when I say up until a certain point, I mean that uh, till the point when you have when you don't have like organizational issues coming up, and when you don't have the like software issues coming up, right? Like you will start having, in case of a monolith, right? As the code base grows, you will start having, and as the number of people start to increase, the like people will start to come into like step on each other toes, right? Like, hey, I'm blocked because of that person, I'm blocked because of this person, right? Because there is no clear uh, boundary of work. So in that cases, usually monolith is the go-to architecture. But as you have, let's say, thousands of engineers, right? Not all thousand of them can work on one single backend code base, right? You need to split the code base. You need to take all the associated like operations in one single microservice and delegate it to one team. And usually that team is responsible only to look after their service. There is definitely one like some level of overlap, but ideally it should be like we should strive for as much as uh, like low overlap as possible. Okay, so I think, yeah, with this, I have covered the gist of Conway's law, that what it is and why we need to split a monolith into microservices, and why DDD is one of the most famous. Iterating it once again because it puts business in the center, and you take all the decisions, like all the technical decisions are taken by taking business as the core driving logic. So yeah, with this, I would like to end it here, and I really hope that you find this useful. If any part of this was confusing or you didn't get it correctly, feel free to comment, and I'm more than happy to help you out there. Thank you so much for your time.